The Archaean Eon began 3.85 billion years ago and ended 2.45 billion years ago. It began with a late heavy bombardment and the origin of life, and it ended with the Great Oxidation Event. It followed the Hadean Eon on this timeline, and it preceded the Proterozoic Eon. The Archaean world was characterized by an anoxic atmosphere, a thick orange haze that only let about 10% of the light through, but cyanobacteria, which lived in the Archaean world, could function at that low level of light. The idea that there was an orange haze was conceived of by Carl Sagan, who noticed the same type of haze on Saturn's moon Titan, and that's been confirmed by geologic strata that have sulfur isotopes which indicate that the Earth was covered by an organic global haze. Although the atmosphere remained anoxic, banded iron formations indicate that there were huge fluctuations in oxygen, at least in the shallow parts of the Archaean oceans, and the alternating red iron oxide and silica layers indicate high dissolved oxygen when the red iron oxide is deposited, and silica layers when the ocean is low in oxygen, and that would have been a symptom of algae blooms, which emit oxygen when they're blooming, and then when they're dying and being consumed by bacteria, the bacteria consume the oxygen, so there's low oxygen. So this is evidence of algae being alive in the Archaean Eon. And you can see here in this graph that the banded iron formations, BIF, extended throughout the Archaean and into the Proterozoic. You can also see that the Archaean has this orange color, which represents the orange haze, and that the Proterozoic is blue, which represents clear skies. You can also see that there's no oxygen, that's the red line, prior to the Proterozoic. So the Archaean, even though algae were emitting oxygen, rocks were consuming the oxygen. So it remained anoxic, at least in the atmosphere. The major climate controversy in the Archaean is the faint young sun paradox, which was also thought of by Carl Sagan. And the reason for this paradox is that the sun was 20% cooler at the beginning of the Archaean Eon, which means that the climate should have been very cold and water should have been frozen. But rock formations that formed during the Archaean Eon indicate that water temperature was at least sometimes between 26 degrees to 85 degrees centigrade. 85 degrees centigrade is almost boiling. Now, Carl Sagan proposed that greenhouse gases kept the Earth warm. So let's review greenhouse gases. This is a diagram of the current greenhouse effect, where on the left you have solar radiation coming into the Earth's atmosphere, and then on the right you have the infrared radiation emitted by the Earth, and some of it leaves the Earth's atmosphere, but greenhouse gases absorb 350 watts per meter squared, so they keep the atmosphere warmer than it would have been without the greenhouse gases. And greenhouse gases can increase the temperature of the atmosphere even at fairly low concentrations. If you look at this figure, on the left is the downgoing solar radiation with 70 to 75% of the total transmitted through the atmosphere. The ozone absorbs the UV light, which is essential for our health. And then the infrared is on the right, and you can see in the carbon dioxide section here that it absorbs radiation in a range that's not absorbed by other gases. So this is radiation that would have just left the atmosphere into interstellar space, but it's absorbed by carbon dioxide and kept in the atmosphere. And then you can also see the other greenhouse gases, methane and nitrous oxide. And the greenhouse effect can be compared to a solar cooker, where shortwave radiation from the sun enters. That's the left arrow. But then the infrared radiation from the cooker is blocked by, let's say, mylar. That's a solar cooker cover. And so it keeps the heat inside the cooker and heats up the pot. One of the most important aspects of analyzing the global warming effect or the greenhouse gases is the carbon cycle. This is the present-day carbon cycle where volcanoes emit carbon dioxide, and then CO2 is also emitted by burning of fossil fuels, and then it's absorbed by marine biota, which would be like algae, and so on. In the early Archaean Earth, the volcanoes did emit carbon dioxide, and volcanoes and methanogens, those are archaebacteria, emitted methane. So scientists try to think about the carbon cycle in the Archaean as they analyze this question. In order for the atmosphere to be warm enough to cause liquid water to form, carbon dioxide would have needed to be at approximately 10%. But siderite that formed at that time indicates that the levels were only about 0.4% compared to 0.04% today. So they were much lower than it would have needed to be to solve the faint young sun paradox. Another idea is that methane solves the faint young sun paradox and would be a greenhouse gas. But analyzing the volcanic emissions and the methane produced by archaebacteria, it's likely that the maximum would only be about 0.1%. And also, methane would have reacted with carbon dioxide and formed that orange Tholen haze, which actually reflects sunlight and causes cooling rather than holds heat in the atmosphere. Another possibility is ammonia, but ammonia would have been ionized as ammonium by solar radiation, which would have caused it to dissolve into raindrops and be precipitated into the ocean. And also, the atmosphere was not strongly reducing during the Archaean, so ammonia could not exist in the atmosphere. There is one possible explanation for the faint young sun paradox. That is that the axial tilt of the Earth was toward the sun. That's called the high obliquity Earth. And that would explain how there's hot waters, because obviously the pole pointed towards the sun would get very warm during the season that it was pointed towards the sun. So that would explain how rocks could form in almost boiling water. The problem with this hypothesis is that scientists have not been able to figure out how the Earth would have tilted back to the present low obliquity or 23-degree angle.